Hello everyone, welcome back to another video. So this is the second video of STL playlist, and if you haven't watched its previous videos, I will suggest you go through the previous videos. And in this video we'll basically talk about sets in STL and how to use them. So sets, there are three types of sets which are provided in STL. One is normal ordered set, second is unordered set, and third is multiset. Now the the key differences are in its properties and how it stores elements in it. So in normal set or ordered set, it stores unique elements. That means even if I insert 2 twice in the set, it will store only once. So it will store only one occurrence of element in the set. And the elements which are stored in set, they are stored in sorted order. That means default it will store in sorted order. That means if I push insert 5 6 1 in, the order can be random, but after inserting in set, if I iterate over set and print all the elements, they will be printed in sorted order. Now second type of set is unordered set, which also stores unique elements, but the order is not sorted, it is random order. Now why there is ordered set and unordered set, two different sets, if the sorted order is better for solving more problems? Because there is difference between time complexity of both of the sets, and internal implementation is also different. So I will discuss it when we are specifically talking on unordered set. And third type of set is multiset. Now multiset stores multiple occurrences of elements. So if I insert an element twice, it will store 2 occurrences of that element. So it is different from ordered and unordered because it stores multiple occurrences, and the order of the elements is sorted. So these are three types of sets. Now we will move into the first type of set and see its how we can use it. So ordered set, if we talk about its internal implementation in STL, it is implemented with using red black tree. So it is a self balancing tree, but it is not necessary to learn right now. So to declare a set, the library which we need to use is set only. But here, as you can see, we are just as we have discussed earlier, I'm using this bit/std c++.h library, which includes this library also. So I don't need to declare include it again. Now to declare a ordered set, there is keyword set, and then I have to declare a data type of that object. It might be int, and we can also create nesting in this set, so we can also use vector, pair, anything. And then set's name. Now the most basic operation in a set is insert. So we can insert elements. Insert means basically add elements to set, and we can add multiple elements. For example, let's say I add one to twice, and then I added 2. Now how to print elements from ST? So the only way to print element from a set is via using iterator. And if you have seen the vector video, the first the iterators pointing to first element of set is same as it was in vector. It is nothing but st.begin. So what I will do is I will declare and I will use a for loop, and I will start my first iterator from st.begin, and the last iterator in set is same as vector, which is st.end, and increment the iterator. Now to print value at that position, I will use star st, because it is iterator, and value, to get the value at that iterator, I have to use star. So if I run this now, so as you can see, I inserted 1 twice, but it was stored only once in the set. That's why I'm getting 1 and 2 output. If I would have inserted any other elements like this, now 3 also comes. Now I can insert 11 first, then 1, 2, 3, but still it will give my output in sorted order. So all the elements are stored in sorted order. Now some important functions of set are, first is erase. So if we can also remove elements from set. So to remove elements, we can do them by two methods. One is by removing by giving a value in erase function. So if I have to remove this 3, the 3 is removed. Now you also need to remember that if the element is not in this set, then this will give you a segmentation fault, because the element is not present in the set. So, and second method of erasing is erasing via iterator. Now how to erase via iterator? What I will do is I will declare an temp iterator, and let's say it is the starting it is pointing to starting element. Now if I erase that iterator, it will remove the first element, which is 1 in ordered set. And this was about erasing. Now the practice for erasing via iterator is you first use another function, which is dot find. So what dot find does, so let me declare let me write the function dot find. Now dot find, via this method we can get iterator which is pointing to a value given here. So for example, now I have declared st.find 3. So now this function will return the iterator which is pointing to 3. Now I can remove this iterator. Now as you can see, 1, 2 and 11 is there, 3 is removed. Similarly, if I just write 11 will be removed. Now there is a standard practice that before erasing you write a if condition that iterator is not the last iterator, which is st.end. If it is st.end, that means we cannot find there is no 11 present in the set. Then we don't need to remove it, right? So this condition basically avoids the segmentation fault. So this was first 3 functions, and other functions are like st.count. So let me just print st.count of 2. So it returns 1 or 0, which basically means if 2 is present in the set or not. So if I print 4, it will return 0 because 4 is not present in set. So all the functions still discussed till here has O of log n complexity, and there are 2 binary search functions, you must have you must have seen this in previous video also on vector. Now what lower bound is? Lower bound is just lower bound returns the iterator pointing to the element which is greater than or equal to 4. So this will return 11 because the first element which is greater than equal to 4 is 11, and I am printing its value. If I don't print this value, it will be this will return iterator, and to print value I am using star. Similarly, if I write 3 here, it will give me it will print 3 because the first element which is greater than equal to 3 is 3 itself. Now another function is upper bound. Now the difference between upper bound and lower bound is lower bound returns first element which is greater than or equal to that element, that value, but upper bound returns the iterator which is greater than that element. So for 3, if I find upper bound, it would be 11. And the complexity of lower bound and upper bound is log n only, because these are binary search functions, and you can if you know binary search, you can also implement these two functions easily. Now there are also some basic of one functions such as st.size, which returns the size of set till now. So size till after inserting this element was 4, and there is also an boolean function which tells me if the set is empty or not. If I don't insert any of this, so it will return 1 because set is empty now. And there is another function st.clear. So these two functions are takes off one complexity, and st.clear takes off n complexity, and st.clear basically removes all the elements which are present in this set. So after printing, there are no elements here. Now this was all about set. I hope you understand this, and questions on this basic questions on this set are just finding a value, finding an element is present in the set or not, or finding unique elements from a given number of elements, something like that. So you can find this type of questions on HackerRank, basically simple set implementation based problems. You can try to solve them. Now second type of set is unordered set. So to declare unordered set, you just have to add unordered and underscore before this st. Now the implementation of unordered set is internal implementation of unordered set is via hash tables, and the basic function, most of functions are same, but just time complexities are different. Now I will run this program itself. As you can see, I inserted 5 elements. The uniqueness is maintained from set and unordered set, but the order here is basically random. It is not random, it is dependent on hash table, but right now let's say it is random. And this insertion function in set takes off log n worst case complexity, but in this st.insert, the average time complexity of insertion is of 1, but the worst case is of n. So you should remember this, that insertion is of 1, but average case is of 1, but in worst case it might take of n complexity. Now why is this of n? Because there are hash collisions in hash tables, so to resolve them it takes of n complexity. This was the first function, which is insert. Now you can also erase an element by value. So how to erase them? Same as normal set. Now it removed 3 from set. Now the time complexity for this is also same as insertion, of 1 for average case, but for worst case it is of n is size of set. Now you can also use iterator. Let's say I erase the first iterator. Now in this case you wouldn't know what st.begin was because the order is random, but let's say we print it first and then get it. So after erasing 3, the set was 2, 11, 1. So st.begin was pointing to 2. Now I removed it and the set is 11, 1. Now the erase with iterator is of 1. So you can use this, but this is not preferred. Unordered set itself is not preferred because hash collisions are sometimes, most of times it will give you TLE while not solving the problem, but after when you, there are many usually on code forces there is hacking phase and people know how to hack unordered sets and how to take advantage of that hash collisions. So they will hack your solution and you will get TLE and your solution will fail. So if there is a question which is solvable by unordered set, it will be solvable by set also. So always prefer set instead of unordered. And this was erase function for value and iterator. Similarly, there are two functions same as set. There is st.find function with value. This is all. This also has time complexity of 1, but worst case of n, and there is st.count, and this also has often worst case time complexity and of 1 average case time complexity, but worst case is of n. And there other functions same as set st.size, st.empty, and st.clear. So st.size is of 1, st.empty is also of 1, st.clear is of n. Similar to set, only this functions you need to understand this of 1 and worst case complexity. So I think unordered set is done. I hope you understood this. Now we will move to the third type of set, and I think one of the most useful set. I personally use it a lot of time. Now this set, I have already made a video on this, but I will explain here on also. But for more details, I have solved 2 questions on this on multiset in that video. So if you want to watch it, you can check it on my channel. So how to declare a multiset? You just have to write this keyword multiset int and st. Now if you see here, after printing this, there are multiple occurrences of same element here. So if I insert this again, it stores the multiple occurrences of element, plus all of them are stored in sorted order. Now functions, first function is insert itself, and the internal implementation for multiset is also based on red black tree, similar to set, but you can also create your own means behavior of multiset using set and map. Means before knowing multiset, I used to uh, just implement a map and set, which is a combination of map and set, which would work similar to multiset. So insert has a complexity of O of log n. Then in this case, there is a difference between erase with value and erase with iterator. Now what the difference is, let's say I erase 1 from the set. Now erasing 1 means erasing all the occurrence of 1. So when you erase elements with value, it will erase all the occurrences of that value. Now second type of erase is with iterator. So for iterator, what I will do is I will write st.erase and I will first find 1 and then erase the element. So I will comment this, and now as you can see, only one occurrence of that one was removed, which is the first. So st.find first finds the first iterator, which is pointing to 1, and it erases that iterator only. So here also erase function has complexity of log n for both of them, erase via iterator and erase via value. Both have same complexity of log n. And the st.find function, so this also has a complexity of log n. Now after that, there are same two more functions. First is st.count. Now in this case, st.count is more important, because in set and unordered set, you know the answer from st dot the answer this will return will be 0 or 1 only, because there is only one occurrence of each element. But in this case, there might be multiple occurrence, so this function is useful in multiset. Similarly, there are you can also use lower bound and upper bound functions. So let's print lower bound of 1. It will return 1 because the 1 itself is the first element, which is greater than equal to 1. If I print 4, it will give me 11. And if I try to write anything which is greater than 11, this iterator will point to st.end, and if you try to get value at st.end, you will get a segmentation fault. So writing this is not preferred. You always find first iterator, then check if that iterator is st.end or not, and then print its value or do any further operation. So this similarly lower bound and then their upper bound. So it will print 11 because the first element, which is greater than 3, is 11. And both lower bound and upper bound has a complexity of log n. Now there is common functions such as st.size. These three functions, st.size, st.empty, this will be repeated in all three types of sets. So st.size basically print size of set, multiset. Then st.empty returns a boolean which says if the set is empty or not. If it is 0, that means set is not empty. And last is st.clear. So st.clear just removes all the elements from this set. Now problems are on multiset are mostly greedy and sliding window type of problems, where you have to find a max element from a sliding window, something like that. So you can also use a priority queue, but priority queue I haven't taught it in this playlist till now. But priority queue is also a way to store elements in sorted order. But in priority queue, you cannot erase a specific element. Here you can erase that specific element by finding its iterator and then erasing it. But in priority queue, you can only access the element which is at top of priority queue. So multiset has a lot of uses. Means I have solved in consecutive 3 contests of lead code. I have solved third problem with multiset. So that's why it is one of the most important topic. And if you want to see the problems on multiset, you can watch my another video where I solved 2 problems on multiset, and I also gave some practice problems. So you can watch that video. And for set and unordered set, right now just solve hacker rank problems on normal set. I don't think there is any necessary to solve more difficult problems, because in those the logic might be difficult. Right now you just need to understand the implementation of set. So for now you can solve hack rank problems. And last thing is nesting. In all sets you can perform you can have nesting in this, like pair or anything, vector, anything. But while ordering, it will give preference to the first element of whatever object you have. If you have vector, the v of the vector's first element, means vector, the element which is present at 0th index of that vector, will be preferred first while ordering. Similarly, if I'm pushing pairs, the first element in that pair will be preferred for ordering. If both of while ordering, if two elements have two pairs have first element same, then it will go to preference will go to second element. So that you must remember. And I think you can also write a custom logic for this multiset, how it should store, how it should sort these elements. You can also I think in this case itself, if I just write greater int, now if I just insert elements and print it. Now here I will use the short auto iterator to print them. Now as you can see, because of this keyword, they are sorted in reverse order. They are stored in reverse order. So 3 is stored first, then 2, then 1. So here you can write your custom sorter function, type of function for complex objects like pair, where you are storing the elements by second element. You can also do that, but you have to write a custom sorter here. That you can check on Geeks for Weeks, or I will also teach it in sorting the last video of this playlist, which is inbuilt functions, in which I will explain custom sorter for sort function. So it will be similar to this only. So yeah, I think that's it from my side, and next video I will publish this video, and all the videos will be in this playlist, so you can get this you can find this playlist on my channel. And next we will meet in next video, and in next video we will discuss all types of maps which is provided by STL. And thank you for watching.